Okay, let's look at finding a particular solution and slope fields, right? So let's dive right into an example, right? Said the problem asks you to show that y equals square root of c minus x squared is a general solution of the differential equation dy over dx is equal to negative x over y, right? For any positive real number c. Right? Then once you've done that, then find the particular solution that passes through x equals 3, y equals 4. Right? So let's do that. Right, so in order to make sure that this function satisfies this differential equation, let's take the derivative and see what we get. Right? So if you take the derivative of y with respect to x, right? And first thing I would do is, since I don't like square root, so I'm gonna rewrite this guy as quantity c minus x squared quantity to the 1/2 power, right? So that way we can easily take the derivative, right? So the derivative is going to be, right, put the power in front, so 1/2. Right, keep the same quantity, which is c minus x squared, and subtract 1 from the power, so it's negative 1/2, right? Then multiply by derivative of inside, which is negative 2x. Right, let's clean this up. Right, there's 2 on top, so you can cancel that, and there's 2 on the bottom. Right, so we will have, so this is going to be, there's a negative sign, so it's going to be negative. Right, so there's x on top, so x over, right, so since you have a negative power, so it's going to be over here, so c minus x squared sits on the bottom. Then you have a 1/2 power, which is equivalent to square root of c minus x squared, right? But remember that the square root of c minus x squared is same as y, so we can write it as negative x over y, right? So this checks out, so you can see that this function solution satisfies the differential equation dy over dx is equal to negative x over y. So this verifies that this is a solution, right? And the next step is that we want to find a particular solution that passes through 3, 4, right? So let's do that. Alright, so all you really have to do is plug in x equals 3 and y equals 4 into here, right? So y equals 4, so 4 is equal to square root of, right, c is unknown, we're trying to find it, minus x squared, so it's going to be 3 squared, so I'm going to put 9 here, right? Then square both sides. Right, so if you squared both sides, you get the 16 is equal to c minus 9, right? Then we can just simply add 9 to both sides, so that will get you 25 is equal to c, right? So therefore the particular solution is going to be y equals square root of, right, we just found that the c is 25, so you have 25 minus x squared, right? So this is a particular solution. All right, so and also let's look at the slope fields for this differential equation right here. So this is our differential equation, right? And I'm gonna cheat a little bit. I'm gonna use a software called GeoGebra, right? So I'm gonna open that up. right? Then if you want to see a slope field, there's a convenient command called slope field, right? S-L-O-P, slope. Actually, there's a slope field. This is the one I want. So, right? Right, slope field. And then what you do is you can put the function, which was, let's see, negative x over y, right? Then hit enter. All right, so it's a little messy, but this is slope field, right? So whichever the solution you would have to kind of follow the flow, all right? And so we need to go through a point that was 3, 4, right? So let's say where's this 3, 4 is, right? And let's see, I have to make it 3, 4. Let's see, can you see it? Actually, maybe not. Hold on a sec. All right, so I just have to move a little bit here. All right, so this is a 3, 4, right? We wanted to find the solution that passes through this point, right? So let's see if this will work. So the solution was y equals square root of 25 minus x squared, right? So if you hit enter, right, so this is the solution curve, and you can see that the solution kind of follows the flow slope field, and it goes through the point 3, 4, right? So that looks promising. All right, so if you want to sketch the slope field, you can use GeoGebra to sketch it. All you have to do is type slope field, S is capital and F is capital, then put whatever the right hand side, which is dy over dx, in it, and it will draw the slope field for you. All right, that's it. I hope that this was clear.